Hi guys, this is the third section in unit module 6, talking about sampling methods and study types. There are 4 ways to collect sample information. You've got an observational study, a controlled experiment, a simulation, or a survey. They're all used for different reasons. The observational study is a way to measure or observe members of a sample in such a way that they are not affected by the study. So that's what all the people who used to, or still do, look at the great apes or the orangutans and just see what they do in their particular environment, but they don't want to affect it. Simulation, they use a mathematical, physical, or computer model to replicate the conditions of a process or situation. So, for instance, if you are looking for what was going to happen when a tidal wave hits, you definitely don't want to create a real tidal wave. You would have a model of the situation to see what exactly would happen. And that's what they say. This is frequently used when the actual situation is too expensive, dangerous, or impractical to replicate in real life. Controlled experiment. In a controlled experiment, that's what they've been doing with these vaccine trials. They divide the sample into 2 groups. One group gets the treatment, and the other group is called the control group. They get some kind of placebo, which doesn't do the same thing, doesn't do anything. Then they compare the effect on the treated group to the control group to see if it actually helps. If there's no difference between the control group and the one that got the treatment, then obviously it's not a good treatment. A survey. When you have a survey, I'm sure you've seen plenty of surveys out there. You ask every member of the sample set some questions, and they use to measure a variable in a sample. Okay, so which type of study method is described in each situation here? Researchers randomly choose 2 groups from 10 volunteers. Over a period of 8 weeks, one group eats ice cream before going to sleep and the other does not. Volunteers wear monitoring devices while sleeping, and researchers record dream activity. Should the sample statistics be used to make a general conclusion about the population? Well, it's a controlled experiment, but they really don't have that many people involved. They've only got 10 volunteers. So there really isn't a good number that you could actually find about a big general population. It's just too small a sample. All right. Oh. Did we go over what kind of a sample it was, though? It's a controlled experiment. Sorry, did not say that. All right, which type of study method is described in each situation here? Students in a science class record the height of bean plants as they grow. Okay, well, this would be an observational study because you're not trying to affect anything. You just want to observe what happens. Should the sample statistics be used to make a general conclusion about the population? Probably not, because they aren't testing anything. They could have different amounts of sunlight, water, fertilizer, any other things, but they haven't really, they're not checking anything. They're just observing. Student council members ask every 10th student in a lunch line if they like the cafeteria food. Should the sample statistics be used to make a general conclusion about the population? It is obviously a survey because they're right there and they ask every 10th student in the line. However, you really cannot use this to make a general conclusion about the population because people who are in the cafeteria line probably like the cafeteria food. If you didn't, you'd bring your own food. So it's already got a kind of a bias towards eating cafeteria food. If you would choose every 10th student just in the random hallway. Go up 400 wing and choose 10 people out of that. You'd have a better sense of what was going on. Or choose, 5 people out of each room and check and see. I don't think that, they shouldn't be used because, like I said, you've already included bias in there by just having the people that are in the lunch line. A pharmaceutical test company asked for volunteers to test a new drug to treat high blood pressure. Half the volunteers will be given the drug and half will be given a placebo. The researcher will monitor the blood pressure of each volunteer. It is a controlled study. You are a little bit, because you asked for volunteers, it's a little bit biased, but you still had to have people with high blood pressure anyway. It's relatively good. You could actually view treatments that way. You could actually get some statistics from that. That would work. Well, there we go. Sampling. Gathering information about an entire population often costs too much or is virtually impossible. Instead, we use a random sample, use a sample of the population. This is important right here, guys. That sample should have the same characteristics as the population it's representing. Okay, so you cannot be pretending to study the effects on teenage boys and then you go sample a bunch of 50-year-olds in a church somewhere. The sample should have the same characteristics as the population it's representing. And there are several different types of it. First, I've got those right here. Sample types. There's 6 different methods used to select samples from a population. And I use these because they had really good pictures that you can really see what they're talking about. A convenience sample. You are selecting any members of the population who are conveniently and readily available to you. So, right there, you can see they picked the first people that are right here. They might have oversampled the orange because if you look, 1, 2, 3, 4, 5, there's only 5 oranges. 1, 2, 3, 4, 5, 6, 7, 8, 9 greens. So they really have oversampled the orange people here versus the green because they picked it conveniently. Self-selected sample. Select only members of the population who volunteer. Well, again, that can create a little bit of a bias, but sometimes it's the only way that you can go, or it's the fastest way you can go. Like, for instance, the one that people who had high blood pressure were asked to volunteer. Systematic sample. Order the population in some way, like alphabetically, and then select from it at regular intervals. So a systematic sample, you could pick up the phone book and pick every 10th person out of it. That would be a systematic sample. A random sample. All members of the population are equally likely to be chosen. That's numbers in a lottery. You've just got them turned around and one pops out. Stratified. Individuals are organized into groups, freshmen, sophomore, juniors, and seniors, and then individuals from each group are selected. And then cluster. Individuals are organized into groups, and then all individuals in one or more of the groups are selected. So you've got them grouped this way, and then these 3 groups are selected. That is cluster sampling. All right. Every 5th person walking out of a movie theater is asked to name their favorite type of movie. The sample is every 5th person. So this goes back to what we were doing before. Every 5th person walking out of a movie. And suggest a population from which is selected. Well, the population would be all moviegoers. Okay. What did I just pull up there? All right. Classify the sample, same situation, but classify it which way? It is systematic because you have every fifth person. So you've got a system for how you're choosing people. Okay. So here are several. A study is done to determine the average tuition that San Jose State undergraduate students pay per semester. Each student in the following samples is asked how much tuition he or she paid for the fall semester. What is the type of sampling in each case? A sample of 100 undergraduate San Jose State students is taken by organizing the students' names by classification, freshman, sophomore, junior, or senior, and then selecting 25 students from each. So that's actually the picture that we had right here. Freshmen, sophomores, juniors, and seniors, and select some from each. So that would be stratified. Okay. Stratified. A random number generator is used to select a student from the alphabetical listing of all undergraduate students in the fall semester. Starting with that student, every 50th student is chosen until 75 students are included in the sample. Okay. Well, we've got a bunch of them mixed in there. Every 50th student is chosen would be systematic, though. That random number generator, that kind of thing, when you give them, that goes with random sampling. The alphabetical listing is systematic, but this every 50th student, that would definitely be systematic. A completely random method is used to select 75 students. Each undergraduate student in the fall semester has the same probability of chosen at any stage in the process. That is definitely a random sample. They even had the definition in there. You have the equal probability. Okay? The freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4, respectively. A random number generator is used to pick 2 of those years. All students in those 2 years are in the sample. Well, that would be our cluster sample. You organize them, and then you pick all of them in each one. So that falls just like our picture into a cluster. An administrative assistant is asked to stand in front of the library one Wednesday and to ask the first 100 undergraduate students he encounters what they paid for tuition for the fall semester. Those 100 students are the sample. Well, obviously that would be convenience, because that fits just like we were doing before. He's standing in front of the library and he asks the first 100 students he sees. So that would just be a convenience sample. So all of these, that's why I said I love those pictures. You guys can go back when you're trying to classify and just look at the pictures and see which one it matches. Hope that helps. Bye.